Hello again, tribe. Welcome into the second video or part 2 of part 3s of the part 1 pattern sequence and series. Now in this part we'll be looking on more of the questions that we'll be using to prepare for the upcoming finals. Now if you are new to the channel, please be sure that you subscribe so that you won't miss when another video gets uploaded. So without further ado, we're gonna go straight into the questions. Now in the first question 2.1 is saying here we are given a quadratic sequence. Now whenever you are given a sequence, it is important first that you write all the information that you know about that sequence. Now here we're talking about the quadratic sequence. Now so let's first write down the terms or the term values that we're given about the quadratic sequence. Now here, what do we know about the quadratic sequence? We know that it has a first difference, so let's calculate those first, which means going to be 2 minus half, which will give us 5 over 2, and then 11 minus 2 is going to give us 7 over 2, and then 9 over 2, we're going to get it by minusing 10, by taking 10 and subtract 11 over 2. Now we have found the first differences. What else do we know about the quadratic? We know that it has what? Second differences. So let's go ahead and do that. I'm going to take 7 over 2 and subtract 5 over 2. That's going to be 1. And then 9 over 2 minus 7 over 2, that's also going to be 1. Now we know that here, the first terms over here, we already have the formulas that we already write them in general. So we know that the first second difference we always equate it to 2a. Then the first term of the first differences, we make it 3a plus b, and then the first term becomes a plus b plus c. Alright, now let's go ahead and jump into the question. So now let's go ahead and go to the first question. Now the first question says, show that the nth term of this sequence can be written as Tn equals to 1 over 2 into n squared plus 2n minus 4. So here what they want us to do is to calculate Tn. So we know that in general, Tn for a quadratic sequence is an squared plus bn plus c, right? Now here we know that to get a, we're going to use the formula 2a equals to 1. Then to get b, we're going to use 3a plus b equals to 5 over 2. Then to get c, we're going to say a plus b plus c is equals to minus 1 over 2. So let's go ahead and do that. Now 2a equals to 1. 3a plus b equals to 5 over 2. And then a plus b plus c equals to minus 1 over 2. Now to solve this, we're going to start with the one that has one variable, and then from there we're going to use that variable to get the second one, then use the variable to get the third one. Now here we divide this by 2 both sides, then it becomes 1 over 2, and then now the 1 over 2 we're going to take it and substitute it here. Now by substituting here, we're going to solve for b. And then to solve for b, we're going to take this 3 over 2 across, and then we're going to get b as 1. Now what about c? So c, we're going to substitute 1 over 2 plus 1 plus c equals to minus 1 over 2. And then this is going to be 3 over 2 plus c equals to minus 1 over 2. And then taking the 3 over 2 across is going to be minus half minus 3 over 2, which is going to be minus 2. Now this means now Tn is going to be 1 over 2n squared plus 1n minus 2. Now simplifying this, we're going to take out the common factor 1 over 2, then it's going to be n squared plus 2n minus 4, and that is going to be our final answer. Now let's go ahead and jump into 2.2. Now 2.2 says let's determine the value of t75 minus t74. Now here Tn is 1 over 2 into n squared plus 2n minus 4. Now the value for t75 minus t74, we're going to substitute on the formula. So it's going to be 1 over 2 75 squared plus 2 into 75 minus 4 minus 1 over 2, and then it's t74 now. which is going to be 74 squared plus 2 into 74 minus 4, right? Then now we're going to go straight into a calculator. When you press that on your calculator, it's going to be 151 over 2. Now 2.3 says that the first differences of a given sequence above forms another sequence. Now 2.3 says the first differences of the given sequence above forms another sequence. Okay, now let's write that sequence. 5 over 7, sorry, 5 over 2, 7 over 2, and 9 over 2. And then as you can see already, remember in the previous question we just calculated 151 over 2, so we're also going to write that as the difference, but we're not going to write the term position for the number. We just know that it's 151 over 2. Okay, now let's go ahead and look over the first question. Now the first question says, is the sequence of the first differences arithmetic or geometric? Now remember in the quadratic sequence we had a second difference of 1, right? As you can see here, now that this sequence is alone, right, we can see this becomes a constant what? Difference, which means this is going to be arithmetic. And the reason is that it has a constant difference. Now let's look at 2.3.2. Now which term in the sequence of the first differences will be equal to 151 over 2? Now to answer this one, you have to understand something. Now if you remember here, 5 over 2, we got this one from taking term 2 of the quadratic, right, and then subtracted it with term 1, right? And when we did that, this gave us 5 over 2 as term 1, right? What about 7 over 2? 7 over 2 was the same thing. 7 over 2, we take term 3, we took term 3 minus term 2, right? And that gave us what? That gave us term 2, right? And then what about the last one here? The last one here, we took term 4 minus term 3, and this gave us this value as what? As term 3, right? Now as you can see the pattern here, whenever we took term 2 minus term 1, it gives term 1, and when we take term 3 minus term 2, it gives term 2. When we take term 4 minus term 3, it gives us term 3, which then means now in 151 over 2, because of we had term 75 minus term 74 from the quadratic, this means now the result position here is going to be term 74. I hope that makes sense. Therefore the answer here is T74. Now let's go ahead and look into 2.3.3. Now 2.3.3 says calculate the value of the 30th. Now 2.3.3 says calculate the value of the 30th first difference. Okay, so now here we're looking at the first differences, so we want to find T30 for that, right? Now if you remember, T30 of the first differences in the quadratic sequence comes by taking term 31 and subtract that with term 30, right? So which then means now what we're going to do is we're going to substitute using the quadratic formula. So the quadratic formula was 1 over 2 into n squared, so we're going to substitute 31 there, plus 2 into 31 minus 4. Now we're going to say minus 1 over 2 into 30 squared plus 2 into 30 minus 4. Now pressing this on your calculator gives you 63 over 2, which is the value of what? Of the 30th term. So now let's go ahead and look into 2.3.4. Now 2.3.4 says calculate the terms in the quadratic sequence, right? If the sum of the first n first differences is 2176. Okay. Now 2.3.4, right? So we want to calculate how many terms are in the what? In the quadratic. Now, so here what you're trying to here's what you're trying to do is calculate the number of terms in the quadratic if now we're given that the first and first differences, the sum of those is what? 2176. So now here what we're going to do is we're going to use the arithmetic sequence. So in the arithmetic sequence, what do we know? So we know that the first term, which is a, it is 5 over 2. Then we know that d is going to be 1. And then we also know that Sn, right, is 2176. We just need to find now what is n. So what are we trying to do here? So what we're trying to do is to calculate the value of n, and then if we have the value of n, that value of n is going to help us to calculate what? To calculate the value of n in the quadratic sequence. Now how does this thing work? Remember here when we're explaining here earlier in 2.3.2, we said that 151 over 2 becomes 74, right? In what? In the first differences. But if you look into the quadratic, you will see that it came from t75 minus t74. So this then means by calculating the sum, for example, if I make an example and say we're calculating the sum of 74 terms, this will mean that these terms came from 75 terms in what? In the quadratic. So I hope this makes sense. So let's go and do that here. So now here we're going to say we're going to use the formula for the arithmetic series, so which means we're going to write it n over 2 into 2a plus n minus 1d equals to Sn. Now the way I wrote it is so that I can be able to do what? To solve for n. Okay, now this is going to be n over 2 into 2 to 5 over 2, 5 over 2 plus n minus 1 into 1 equals to 2176, right? So now what I'm going to do is I'm going to take the 2 and multiply it over so that I can be left with n, and then this one cancels with that. Then it's going to be 5 plus n minus 1 equals to, so now multiplying 2176 by 2 gives you 4352. Now what do I do with this now? Now I take this one here first, I first simplify what's inside, so this is going to be n plus 4 equals to 4352, right? Then now here n times n is going to be n squared plus 4n is equals to 4352. Then I'm going to write the standard form. 0. So this then means now here a is equals to 1, b is equals to 4, and c is equals to minus 4352. Now applying the quadratic formula, it's going to be minus b plus minus b squared minus 4ac all divided by 2a. So let's go ahead and substitute that. So it's going to be minus into 4 plus minus 4 squared minus 4 into 1 into minus 4352 all divided by 2 into 1. Now pressing this on your calculator, you're going to get two solutions. First solution is going to be n equals to 64, and then the second one is going to be minus 68. But now you know that n can never be negative, so n is equal to 64. Now this position is the position of what? Of the sum of 64 terms in the first differences. But now if we have 64 terms in the first differences, it means now that it came from what? From 65 terms in the quadratic. Therefore n is going to be 65 in what? In the quadratic sequence. So I hope this thing makes sense, and that is all for the part 2, and I'm gonna see you on to the next part series.